What's the formula to find the area of two similar figures?
Side over side, area over.
Close. Almost there. Side 1 over side 2 equals area 1 over area 2. I am missing something super important. Square the sides. Good. All right, so what is the side from the first figure? 12. And the side from the second figure? 6. The area from the first figure? 30. And then the area of the second, we're going to call x. We can reduce if you want. What is 12 over 6 reduced to? Yeah, so we're going to do 2 over 1. So that when we cross multiply, we still have a fraction. And it will equal 30 over x. 2 over 1 squared is the same thing as 2 over 1 times 2 over 1, which is 4 over 1. Oop. And it equals 30 over x. We're going to cross multiply. I'm going to give myself a little more room. Cross multiply, we get 4x equals 30. Divide by 4. You could have two separate answers. You could reduce. What's 30 over 4 reduced to? 15 over 2. Or you could make it a decimal, which is 7.5. And you'd say it's feet. So feet squared or squared feet, same thing. All right, the next one, list all pairs of congruent angles. And then there's other stuff. So what's the easiest way to list all the pairs of congruent angles? Yeah, just look at this. So we would say angle L, it's okay. Angle L would be congruent to angle A. Angle N is congruent to angle B. Angle M is congruent to angle C. Okay, so that's the first part. Make sure you read the directions on your quiz, because I already saw a lot of people skip some of this question. It says then write the ratios of the corresponding side lengths in a statement of proportionality. So first off, what does a ratio look like? A fraction. So we're writing the fractions of the side lengths in a statement of proportionality. So what that meant, this was the where you made three fractions because there are three sides. Pick a side off of the first figure, LN, which corresponds with AB. Pick another side off of the first figure, NM, which corresponds with BC. And then last, sure, if we say ML, we would say CA. That's the end of our question. I'm pretty sure on your quiz it does ask for a similarity statement, which we'll practice in a few minutes. So make sure you just read the directions all the way through. Okay? All right, this next one, it says show that the triangles are similar, then write a similarity statement. So basically what you're looking for with triangles being similar, you're looking for two angles that are congruent to two angles. So from here, let's look at our triangle. Do we have an angle congruent to an angle? We do. We got 57s. So we're going to name them congruent. When I name this angle, this first one, do I need one letter or three letters? One letter, because there's only one angle. So you could say angle A. You can use three letters if you want. You're not wrong. But here, because there's only one angle in that corner, you could say angle A, and it would be congruent to angle D. Do we have another set of angles that are congruent to each other? Which ones? The vertical angles, because they share a vertex. All right, so if I wanted to name this left portion, could I use the letter C? I can't, because there's this angle at C, there's this angle at C, there's this angle at C, this angle at C. Too many. So if I wanted to name this one in particular, what can I name it? What'd you say?
ACB.
ACB. So the letter C needs to be in the middle. So you could also say BCA. It is congruent to, DCE. All right, and it says write a similarity statement. So this is when you name a triangle. Go ahead and name the first triangle. ABC is similar to triangle DEC. So A and B are the same measure. B and E are the same measure. C and C are the same measure. All right, so both of these are your answer. This is us showing that the triangles are similar. This is us writing a similarity statement. The next, find the scale factor from the larger to the smaller. Smaller to larger? It's fine. It's Monday. So sorry. Forgive me. Pick a side off of the first figure. Sure. So 18, we're finding the scale factor, times the scale factor, which we'll call x, will give me what side length? 45. Good. Divide by 18. All right, they're both divisible by what number? Higher than 3.
6.
Nope.
3.
9. How many times does 9 go in 15? 5. And then how many times does 9 go in 18? 2. So what would the scale factor be from the larger to the smaller? 2 over 5. It'd be the flipped if it were the other direction. All right. It says in the diagram, ABC is similar to WXYZ. Find the perimeters. I don't think you have your information. This is not printed on yours. So you can go ahead and write it in because it is necessary. All right, so what we do, the perimeter formula is side 1 over side 2 equals the perimeter of the first over the perimeter of the second. So, what is the length of the first figure side? 32. So if I use 32 in the first figure, what do I have to use in the second figure? 8. All right, and it will equal the perimeter of the first, which is 100, over the perimeter of the second. I'm just going to call it P. Cross multiply, we get 32P equals 400. Divide by 32. So what is the perimeter of the second figure?
25.
It's 25. We're going to say 25 units.
It should be 32 over 8.
Over 8. I'm sorry. Go back. It is a Monday, isn't it? I don't know where, I know where I got 4 from. I did it in my head. So 32 over 8, sorry. In my head I reduced it to 4. So sorry. I'll tell you why I did that in a second. So we would get 8 times 100, which is 800. 800 divided by 32 is 25 units. There's a question on your quiz, and it says, it doesn't say find the perimeter, it says find the ratio of the perimeters. So the ratio of the perimeter is the same as the scale factor. What is the scale factor from the larger to the smaller? So it went from 32 to 8, so it is close.
4 over 1.
Nope.
4, 1 over 4.
1 over 4, so it's a fourth, right? What's a fourth of 100? 25. So on your quiz, it's going to ask you what the scale or what the ratio of the perimeters are. It's the same as the scale factor. Does that make sense? That's why I wanted to tell you that. So sorry for the mistake. All right. Next page, the polygons are similar. Find the value of x. So if the polygons are similar, what do I know about the side lengths? They're proportional. So I'm going to make a proportion. All right, so we're going to set up a proportion. starting with x. What does x correspond with on the other figure? 7. All right, and then we're going to pick another side from the same triangle as x. So pick a side, any side. Sure. 18, which corresponds with 6. You can reduce if you want to, but again, if you reduce, I'd leave it as a fraction. What does 18 over 6 reduce to? 3 over 1. So cross multiply, you would get x equals 21. Good. Sorry, we have to speed up. So sorry. Determine if the two triangles are similar. If they are, state how you know. If they are not, explain how you know. So either way, we're telling why we know what we know. So basically, if these are similar, what do we know about the side lengths? The sides are proportional. Proportional. That's what we're looking for. Okay? Sides being proportional. So, go ahead and pick a side off our first triangle. Sure. 16. We're going to see if 16 over, what does 16 correspond with? 20. We're going to see if it is equal to, pick another side off of this first triangle. 20. We're going to see if that's equal to 20 over 26. And then last, see if all of that equals 12 over 15. We're seeing if they have the same ratio, okay? So you can set these equal. Notice how all the top is from the first figure, all the bottom is from the second figure. That matters. Go ahead and reduce 16 over 20, which is?
0.8.
Yeah, so 4/5 or 0.8. And then 20 over 26 is?
5, 6. No.
10 over 13. So already, do they have the same? No. So they're not proportional. The last one would have reduced to 4/5. But because the third side is not proportional, these are not similar. So we're going to say not similar. Again, because the sides aren't proportional. Another way to do this is to figure out what the scale factor is for each side and then see if all the scale factors are the same. Okay, they wouldn't be. Sorry, we just got to keep moving. Determine whether the polygons are similar. If they are, write a similarity statement. So this one's pretty easy. You need to see if the same number was multiplied, if they have the same scale factor. Okay? What is the, we'll do this as easier. What's the scale factor from QT to HT? 5. What about from 5 to 25?
5.
It's still 5. Over here it's 5. Over here it's 5. So, are the sides proportional? Yes. Are the corresponding angles congruent? Yes, they are. So then these are similar. You're going to make a similarity statement. So name the outer rectangle first. Yeah, HIJK is similar to QRST. If they weren't similar, you would write not similar. That's it. Find the value of x so that BC is parallel to DE. All right, so basically if the lines, if a side of the triangle is parallel to a side inside of the triangle, then these sides, the other two sides, are broken up proportionally. So we're going to set x minus 2 over 16 equal to x minus 3 over 14. I would not reduce in these problems ever, unless you are confident you know how to. Because it would look like you could reduce this first fraction, you cannot. Because this is x minus 2, this is what I call a family. They're attached. They would both terms would have to be divisible by the same number for you to reduce, and they are not here. So if you aren't confident in your reducing skills in this aspect, do not do it. I recommend don't do it. Okay? So if that's the case, the second one definitely can't be reduced either. You're going to cross multiply. I'm going to do 14 first. 14 times x minus 2 So then it'll be 16 times x minus 3. Distribute, so I'll get 14x minus 28 equals 16x minus 48. Subtract 14x. Sorry, y'all, I told you we have to speed it on up. Add 48. What's 48 minus 28? 20 equals 2x, so x equals 10. You're going to clear your desk of anything besides a pencil and a calculator, and y'all are also going to spread out.